our ecological environment and endanger aquatic life. No doubt there are some conventional treatment systems like gravity separation, chemical treatment, but they have some drawbacks like high capital cost, high O&M cost, complex operation. So there are some recent progress in oil water separation, like using special wettable materials like oil removal, water removal, and they are being used by using the technology like filtration and adsorption using meshes, membranes, porous media like sponges, foams. All these processes have the high efficiency and the capacity, but they have some problems like high cost of material, generation of secondary pollutant, depletion of natural resources. So how can we overcome these problems? Why not to have adsorption and filtration together? So our solution is use of hydrophobized porous grains because the surface area of porous grains are greater than the solid grains. It's our hypothesis that if this is a hydrophobized porous grains which have external pores and interparticle pores, and this is hydrophobized solid grains, then the porous grain will have adsorption plus filtration, while the solid grains will only do filtration through chromatographic behavior. So there is another challenge and how to overcome it, which is management of construction demolition waste and industrial byproducts. In developing countries like Vietnam, the recycling rate is very low and the main treatment method is dumping and landfilling. You can see in this picture. So why not to use these effective low-cost CDWO and IBPs for oil water separation by using waste to resource strategy, and it will add value to the waste and which will promote recycling and reuse. So in our literature review, we have focused on adsorption and filtration techniques using hydrophobized porous grains or the solid grains. Very limited research have been there for hydrophobized solid grains, and all these research says that if we have a higher contact angle, then we can achieve higher separation efficiencies and separation capacities. Look at this figure. This is an example of lotus leaf, which is hydrophobic in air and oleophobic in water. So many of you will be thinking that what is contact angle? So we can assess contact angle by measuring contact angle of water in air, which I will say CAA, and it will represent the hydrophobicity and oleophilicity, while the second is CA0, which represent contact angle of oil in water, and it will represent oleophobicity and hydrophilicity. So basically the oil water concept is based upon CA and CA0. In this figure, this mesh is hydrophobic, and you can see here that the oil has been eluted while the water is retained, while in this figure the hydrophilic and hydrophobic desert sand has been used and the water is eluted and the oil is retained. So significance. So why we are using porous grains? Recently, the adsorption capacities of heavy metals in treatment of oily wastewater has been studied by utilizing industrial byproducts and CDWs. So the conclusion